Hello, I'm the product manager for Hoperf sensor product line. Today, I'm delighted to be here to introduce and share our company's sensor products with all of you. First, let's take a look at the classification of pressure sensors. Pressure sensors are mainly divided into three categories. The first category is called absolute pressure sensors. Absolute pressure sensors measure the change in pressure relative to absolute vacuum. The second category is called gauge pressure sensors. Gauge pressure sensors primarily measure the changes in pressure relative to atmospheric pressure. The third category is called differential pressure sensors. Differential pressure refers to the change in the pressure difference between two pressure sources. Different types of pressure sensors have different application scenarios. These we will further describe and explain in the following sections. From the technical perspective of the products, pressure sensors can also be divided into piezo-resistive pressure sensors and capacitive pressure sensors. Piezo-resistive pressure sensors have a Wheatstone bridge resistor fabricated on a silicon diaphragm. Due to the mechanical stress on the silicon diaphragm causing deformation, the deformation leads to a change in the resistance of the Wheatstone bridge, thus altering the output voltage signal. The capacitive pressure sensor is also a structure similar to a Wheatstone capacitor bridge. When pressure is applied to the diaphragm, the distance between the two capacitor plates is changed, thus altering the balance of the capacitive bridge, resulting in a different output voltage signal. Due to differences in manufacturing processes, capacitive pressure sensors have lower power consumption, more stable temperature characteristics, and therefore higher measurement accuracy. However, their measurement range is relatively narrower. Next, let's introduce the internal structure of pressure sensors. A mature pressure sensor needs to go through packaging, calibration, and testing before it can be delivered to users for use. During packaging, we usually need to use two chips to complete the process. One of the chips is called MEMS. It is primarily used to sense pressure and convert pressure into voltage. The other chip, we call it a signal conditioner, or ASIC for short. It is mainly responsible for processing the voltage signal and outputting digital signals to the external MCU. The two chips are attached to a substrate and are interconnected by gold wires. We will place a metal casing on the outside of the chip and the substrate to protect the gold wires and wafers from damage. After the product is packaged, we need to perform calibration. During calibration, we mainly compensate for temperature and pressure to ensure it meets the linear output characteristics and has long-term consistency and stability. Finally, we need to test the product to check the various performance indicators of the product and whether the specifications meet the application requirements. Next, we'll briefly discuss the applications of pressure sensors in daily life. In smart cities, pressure sensors and temperature and humidity sensors have a wide range of applications. Among them, pressure sensors are used in indoor and outdoor navigation for applications such as altitude tracking, altitude positioning, and floor positioning. In the automotive field, the most common application of pressure sensors is tire pressure monitoring. It can monitor the pressure changes of the four tires in real time. In warehouses and production areas, pressure sensors can also be used for tracking assets and personnel. In the field of smart home, by using temperature and humidity sensors, pressure sensors, and some gas sensors, we can create and set a more comfortable living environment. In the field of outdoor sports, through sensors, we can monitor the trajectory and distance of the movement, and help us calculate the calories consumed. Next, I will introduce the typical applications of pressure sensors and temperature and humidity sensors in daily life, one by one. First is the smart thermostat. The smart thermostat can monitor temperature and humidity in real time, and it is also connected to the air conditioner and fresh air system through wireless signals. Thus, we can automatically adjust the temperature and humidity in the air, as well as the opening and closing of the fresh air system, to create a more comfortable living environment and achieve better energy-saving control. In the field of portable weather forecasters, the application of various sensors is also very extensive. For example, we can use temperature and humidity sensors to monitor the changes in temperature and humidity indoors and outdoors. Monitor atmospheric changes through barometric pressure sensors, and predict future weather changes. Through wind speed sensors, rain gauges, and even solar radiation intensity sensors, customers can be provided with effective, local real-time weather forecast information. One of the most widely applied fields for pressure sensors is as altimeters or barometers. By continuously monitoring changes in atmospheric pressure, we can calculate the current altitude, or the pressure at sea level. This is widely used in many mountaineering and outdoor sports. In the field of sports and fitness, pressure sensors can monitor very small changes in height. For example, the height changes during push-ups or pull-ups. They can even monitor directional movement changes. Therefore, many wearable devices are equipped with pressure sensors. Outdoor sports such as mountaineering, running, cycling, swimming, surfing, diving, etc., all require monitoring of the external environment. At this point, the pressure sensor can calculate the current air pressure, and calculate the current altitude, and even predict future weather changes, among other things. Additionally, it can be used for positioning and navigation, and it can also measure the depth of diving. Therefore, it has a wide range of applications in wearable devices for outdoor sports, and can be considered a standard configuration. In some security products, pressure sensors can use changes in pressure to calculate the height of a free fall. Therefore, it also has a wide range of applications in detecting and determining fall states. In indoor and outdoor positioning and navigation applications, especially in scenarios where there is no GPS signal, pressure sensors can accurately determine the height of the floor and the altitude, thus providing rescue personnel with more precise location information. One of the most widespread applications of pressure sensors is altitude control in drones. By monitoring real-time pressure changes, drones can control their flight altitude, ensuring the stability of the aircraft. In smart vacuum cleaners and fresh air systems, pressure sensors also perform well. By monitoring the pressure changes in the air ducts and dustbin, we can detect whether the dustbin is full, whether the filter of the new air system needs to be replaced, issuing necessary prompt messages to inform customers to replace the filter or deal with the dustbin. In the field of general industrial applications, pressure sensors are widely used in ultrasonic metering instruments. Due to the thermal expansion and contraction of gases, When ultrasonic gas meters measure gas flow, there will be some loss. Pressure sensors can accurately measure the pressure and temperature of the gas in the pipeline, thereby providing temperature and pressure compensation for ultrasonic flow meters. This can effectively reduce the measurement loss of the ultrasonic flow meter. Now let's introduce the absolute pressure sensors from Hoperf Electronics. The 5 products you see here. The previous model is a piezo-resistive absolute pressure sensor. The last 2 are capacitive pressure sensors. From the product specifications, we can see that the measurement accuracy of capacitive pressure sensors is generally higher than that of piezo-resistive pressure sensors. However, the biggest advantage of piezo-resistive pressure sensors is their measurement range is wider, covering a broader range of pressures. In many application scenarios that require a larger pressure range, piezo-resistive pressure sensors are a better choice. All pressure sensors support the I2C digital communication interface. The operating voltage is generally 3.3 V. We offer package sizes ranging from 3.8 mm asterisk 3.6 mm to 2.5 mm asterisk 2.0 mm, with multiple sizes available for users to choose from. Our company also offers waterproof pressure sensors, all of which are of the absolute pressure type. The first 3 are piezo-resistive pressure sensors. The last 2 are capacitive pressure sensors. Similarly, for capacitive pressure sensors, the pressure range is narrower, but the measurement accuracy is higher. The product sizes we offer range from 6.8 mm asterisk 6.2 mm to 4.5 mm asterisk 4.5 mm, as well as the smallest size of 2.7 mm asterisk 2.7 mm. Convenient for users to choose according to their needs. All products support the digital I2C communication interface. The operating voltage is 3.3 V for all products. According to customer needs, we can also customize products for customers. By changing the process, the products can be made to have anti-corrosion capabilities. In some harsh application environments, such as gas and sewage treatment where anti-corrosion applications are needed, we can provide corresponding products. Our company also provides 3 types of gauge pressure sensors. The product is available with metal nozzles and plastic nozzles. The size ranges from 9.0 mm asterisk 9.0 mm to 10.3 mm asterisk 7.0 mm. Since they come with metal or plastic air nozzles, customers find them more convenient to use, and the structural design is simpler. There are multiple pressure ranges available for users to customize. The operating voltage ranges from 3.4 V to 5 V are all supported, and they also support the digital I2C communication interface. Finally, we also provide temperature and humidity sensors. Both products are characterized by their small size and high measurement accuracy. The T09 temperature sensor has a measurement accuracy of plus or minus 0.2. The TH09C temperature and humidity sensor has a temperature measurement accuracy of plus or minus 0.15. The error of relative humidity can reach plus or minus 2%. Both products have a very small volume. The package size of T09 is only 1.5 mm asterisk 1.0 mm. And the package size of TH09C is only 2.0 mm asterisk 2.0 mm. In some applications that require a more compact scene, these 2 products are the best choice. Next, Let's introduce the product advantages of our Hoperf company. First, our company has the independent design capability at the chip level, able to continuously expand the product line and iterate products. Second, after years of technical accumulation, we have the design, development, packaging, calibration, testing, etc. of sensor products, the technical capabilities of the entire industry chain, able to provide customers with better technical support and services, helping customers accelerate their time to market. If you are interested in our company's sensor products, please feel free to contact our sales personnel in a timely manner, or reach out to us through our WeChat official account or our official website. Thank you all.